Okay, next example, it says a dog trainer has 100 meters of chain link fence and she wants to enclose 250 square meters in 3 pens of equal size as shown on the right. So pay attention to the 100 meters, which is really just the amount of chain that needs to go all the way around and then cover the middle part as well. And the area she wants to enclose is 250 square meters. So area is 250 square meters. And then the perimeter really, along with the middle sides, is how much the 100 meters of chain is going to go to. So I made a note of the area. The perimeter is all the way around. However, this problem doesn't only have material all the way around, there's also stuff in the middle that the 100 needs to be covering. Part A says let L and W represent the length and width of the entire area. So this is the entire area we are looking at. So this entire area has to be 250, and the length and the width represent the entire place. So the width is right here, and the length, I guess, is the entire place right here. Write an equation about the amount of chain link fence. Okay, so if this is L, this bottom part has to be L. If this is W, across from it is W. However, the chain not only has to go all the way around, but fill the insides as well. So fill that W and fill that W. So I have to add up everything and equal it to 100 meters, which this is how much the dog trainer has available of. So I have L and L, that's 2L, plus 1, 2, 3, 4 W's. Remember, I'm not multiplying, I'm adding the W's, so not W to the 4th, but 4W, equals 100 meters is available for all of this. There's our equation for part A. Part B, solve your equation for L in terms of W. In other words, have L equal something from this equation. So I'm going to take that equation and isolate L by moving 4W, subtracting it from both sides. 2L is 100 minus 4W. Divide everybody by 2. L is 50 minus 2W, it looks like. So now I have L as 50 minus 2W. So we're good with A, we're good with B. Part C says, write and solve an equation in W, I guess in terms of W, for the total area enclosed. Okay, so the total area enclosed, remember, was 250 square meters. We also know that area is length times width. So length times width for this problem has to be equal to 250. Now we know the width is W, and we also know that the length is this. So the length and the width are going to get plugged in accordingly. Length is 50 minus 2W, and the width is already in terms of this W they asked for anyway, equals 250. So there's my equation for area once I've replaced the L with in terms of whatever it was in terms of W. So I'm going to continue with this equation and solve it. Distribute the W, that's 50W minus 2W squared equals 250. And we're supposed to solve the equation, so since it's a quadratic, I'm going to move everything to this side because I want my leading coefficient again to be positive, just because I like it that way. You don't have to do it that way. So I'm going to move the W to this side. Now I have 0 equals 250 minus 50W plus 2W squared. I'm going to write it in standard form, which it already really is in standard form, but I like my 0 on the right side. So there is the equation in standard form set equal to 0. Now I can try factoring this and popping out W, the solutions for W. I can try completing this square, or now that we know about the quadratic formula, I'm just going to go ahead and use A to be 2, B to be minus 50, C to be 250, and solve this using the quadratic formula. So quadratic formula is usually x equals this, but since my variable here is w, I'm going to say w is going to be solved for. Negative b will be the opposite of minus 50, which is positive 50, plus or minus negative 50 squared minus 4a, and then c all over 2a. We're going to simplify that further, and that's going to give me 50 plus or minus, it looks like 2500 minus 2000 is 500 all over 4. Then I'm going to simplify further by approximating square root of 500. So square root of 500 is 22.36067977. I carried some digits. It's either 50 plus it divided by 4 or 50 minus it divided by 4. So basically W is either 18.1 meters or W is 6.9 meters. And did they want, let's go back up, did they want us to find the length also? Find the dimensions. So that's part D. Find the dimensions. Maybe we'll do it down below. So we found the equation. We solved for W using the area. Now we're going to go find the dimension. We found W. L, remember, was 50 minus 2W. So now I have to go do 50. L is 50 minus 2W for both of these cases. So we found two possibilities. We could either have the person make the regions have a width of 18.1 meters and corresponding to that a length of 13.8 meters, or we could have the region have a width of 6.9 meters and a corresponding length of 36.2 meters. So based on what we had talked about up above, this was the W, this was the length. So it could be 18.1 meters for these parts and then 13.8 meters across, or the other scenario would be you could have 6.9 meters like this and then 32.2 meters across. Either way, when I add 4 W's and 2 W's with these two guys or these two guys, I better get 100 because there was 100 meters available to begin with. Find the coordinates of the intercepts and the vertex and sketch the graph. So I'm going to say y-intercept first. I'll make x equal to 0 in here, and that's going to give me, everything is going to get dropped because x is 0, and I'm going to only be left with 4. So y-intercept is 0, 4. Then I'm going to make my own little part for the x-intercept where automatically y has to be 0. So when I make y equal to 0, I get this quadratic equation, and I can solve this either using the quadratic formula or factoring. I think this will be factorable, so I'm going to go ahead and move this up instead of the quadratic formula and get negative 8, negative 2 times 4. That is factorable. X plus 8, x minus 1 equals 0. Since I multiplied by negative 2, I got to divide by negative 2. That's going to give me 0 equals x minus 4, and negative over negative is positive. Move the 2 up, 2x plus 1. So there's really two x-intercepts. One is x equals to 0, and the other one x equals negative a half. So since it said coordinates, I have to give them as ordered pairs. 4, 0, and negative 1 half 0. And then part C, I'm going to find the vertex. So I'm going to do x is equal to negative b over 2a, and this is my a, this is my b, that's my c. So negative b would be negative 7 over 2a, a is negative 2. That's negative 7 over negative 4, which is really 7/4. So if 7/4 is really bothering you, you can put that in and see that that's just an x-coordinate of 1.75. Now for the vertex, I have to go find the y-coordinate by plugging this back into the original equation. So 1.75 is going to get plugged into all the x's. and we'll see what y value it spits out. So I'm getting a 10.125 for the y coordinate of the vertex. So the ordered pair is 1.75 for the x coordinate and 10.125, which I'll have to approximate when I graph it, for the y coordinate. So ultimately here are the things we have. We have the y-intercept, we have two x-intercepts, and we have the vertex. And we're going to go plot these guys on the grid here. And remember, don't forget about this minus, because that minus is going to make the parabola open down. So 0, 4 is right here. That's my y-intercept. 4, 0 is the first x-intercept, and negative a half 0 is the second one. So right there. It's not cooperating. There we go. It's good enough. And then vertex 1.75, so between 1 and 2, closer to 2, and a little bit above 10. So I'm just going to guess and say it's somewhere over there. So I got my vertex up above, 1.75 to the right, and just barely above 10. Then I got my two x-intercepts and my y-intercept, and I'm going to make a parabola opening down. And there's our parabola. We found the coordinates of the intercepts, meaning x-intercept and y-intercept, and also the vertex, and we sketched it. Okay, next one, we'll go through the same steps. So I'm going to say y-intercept, automatically make x0. When I make x0, these x parts drop, and I just get y equals 7. So coordinates 0, 7. B, we'll go through it quickly. X-intercepts make the y0. Always, when I make the y0, I get 0 equals x squared plus 4x plus 7. This guy is not factorable, so I have to use either completing the square or, better yet, the quadratic formula. So I have a1, b4, c7. We'll do negative b plus or minus b squared minus 4a and c all over 2 times a. That's going to be negative 4 plus or minus 16 minus 28. And I think I'm going to stop there because I get a negative number. I'm going to say no x-intercept. So this parabola will not have any x-intercepts because the discriminant is less than 0. I don't even need to continue further for trying to find x-intercepts. I'm going to go to the vertex next. X equals negative b over 2a. So negative b would be negative 4. 2 times a is 1. That's going to be negative 4 over 2, which is negative 2. I have to plug this back in here to get my y coordinate of the vertex. And when I do that, it looks like I get a 4 minus 8 plus 7, which gives me negative 4 plus 7, which is a 3. So the vertex is negative 2, 3. So what do we have so far that I can graph? I just have this coordinate, which is the y-intercept, and I have this coordinate, which is the vertex, and I do know that it's got a positive leading coefficient, so it's going to open up. If I need any more ordered pairs for accuracy, I can make an xy chart. So let's go plot 0, 7, 5, 6, 7, and then negative 2 to the left, 3 up. And I do know that it opens up, so it's going to go something like that. If I need another accurate point, I can use the axis of symmetry like this. I can cheat instead of making an xy chart. So since the axis of symmetry goes all the way through the vertex, always through the middle of the parabola, I made it there, and I'm thinking if from the axis of symmetry I go 2 steps to the right, I get this y-intercept. Its image would be 2 steps to the left. Now that should be enough, 3 dots, for me to make a nice parabola. And we're done.